We will solve today some gate questions on computer network of 2017. Okay, it's given that consider a binary code that consists of only four valid code words as 00101 and 11110. Okay, then let the Hamming distance minimum of the code is P, and the maximum number of erroneous bits that can be corrected by the code BQ. Then the values of P and Q are: option A is P is equal to 3, Q is equal to 1. Option B, P is equal to 3, Q is equal to 2. Option C, P is equal to 4, Q is equal to 1. And option D is P is equal to 4, Q is equal to 2. Okay, so what is the problem given? That consider a binary code that consists of only four valid code words as 00000, 01011, 10101, 11110. Let the Hamming distance minimum of the code is P, that is Hamming distance is P, and the maximum number of erroneous bit that can be corrected by the code be Q. Then the value of P and Q are, this four option is given. Okay. So if you see the code, let us see what are the code. 5 zeros, then 01011, 10101 and 11110. So if you see all this code, if you take the XOR operation of any of the two, by this one, or this one, or this one, or this one. So let us take one 00000 and let us take this one 11110. So if you take the XOR operation, you will get this, that is at least you get four ones. Okay, 4 1. Okay, also the minimum number of ones is, if you consider how many after doing the XOR operation among these bits, let us take this any arbitrary one. So you will see that it will be 1011, that is 3. Okay, so after XOR operation at each code word, we found that minimum number of ones of each word is 3. Okay, so each word, if you do any XOR operation, you will see the minimum number of ones is 3. Okay, so if you take these two, 1 1 1, so minimum is 3. Okay, so for correction of D error, so we can say that, okay, so by seeing this, what we can say that, so after XOR operation of each code words, we found minimum number of ones in each word is 3. Okay, so therefore for correction of D error is 2D plus 1 equal to 3, which implies that D is equal to 1, and that is nothing but Q. Okay, so Q is 1 and this your P will be 3, so we can say that P is equal to 3 and Q is equal to 1. So P is equal to 3, Q is equal to 1, so option A is the correct answer. Okay, now let us try another problem, again GATE 2017. So it is given like this way. Consider, it is from computer network, consider two hosts X and Y connected by a single direct link of rate 10 to the power 6 beats per second. The distance between the two hosts is 1000, that is 10,000 kilometers. Okay, so this one is important, and the propagation speed along the link is 2 into 10 to the power 8 meter per second. Okay, host X sends a file of 5000 bytes, that is 50,000 bytes, as one large message to host Y continuously. Let the transmission and propagation delay be P and QMS milliseconds. Okay, then find P and Q, and it is given that option A P50 Q100, option B P50 Q400, option C P100 Q50, and option D P400 Q50. Okay, now we know that to solve this problem, so let us read the problem once. Consider two hosts X and Y connected with a single direct link of rate 10 to the power 6 bits per second, that is communication will be happening in 10 to the power 6 bits per second. The distance between the two hosts is 10,000 kilometers, and the propagation speed along the link is 2 into 10 to the power 8 meter per second. Host X sends a file of 50,000 bytes as one large message to host Y continuously. Let the transmission and propagation delay be P millisecond and Q millisecond. Then what is the value of P and Q? And these four options is given. So we know that the transmission time or delay equal to distance by bandwidth. Okay, so distance is, you see, transmission time by bandwidth. Okay, so sorry, it is not a distance, it is data size by bandwidth. Data size by bandwidth. And what is the data size? Data size is 50,000 bytes. So 50,000 bytes. So now we will convert the bytes into bits. So into 8 divided by bandwidth. Now bandwidth is given this one. This one is the bandwidth, and this is in bits. So I have to convert this data 50,000 into bits. So 10 to the power 6. So if you calculate this, you will get something, this 40. So 40 means another thing. So you will get 6. So you will get 400 bits per second. Okay. So this one. Now propagation delay is equal to, that is nothing but, this is q, sorry, this is p. Okay, and propagation delay is q. Let us, if you denote this, that is distance by velocity, and the distance is given this one, 10,000 kilometers. 10,000 into 10 to the power 3, now converted into meters because this is in meter, and this is 10 to the power 8 meter per second. Okay, so it will give this one. Okay, so we will get 400 and 500, sorry, 50. This is 50. Okay, so this is 50. So your answer will be P is equal to 400 and Q is equal to 50 m second. So your 400 means this one. This is option D is the correct answer. Okay, now let us do another problem. So it is also came in gate 2017 from computer network. Question is given, consider the following about routing protocols routing information protocol or RIP and OSPF, that is open shortest path first, in an IPv4 network. So consider the following about routing protocol, routing information protocol, RIP and OSPF, these both in an IPv4 network. Now the 4 option is given. Now you have to choose which one is right. First option is RIP uses distance vector routing. Now obviously this is correct. Number 2, RIP packets are sent using UDP. Option 3, OSPF packets are sent using TCP. option 4, OSPF operation is based on link state routing. So this 4 option is given. Now which one is correct? Option A 1 and 4, option B 1, 2 and 3, option C 1, 2, 4, and option D 2, 3, 4. Okay, so let us see this. So we know that RIP, that is routing information protocol, uses distance vector routing and, so I write plus, and uses hop count as a metric. We know that. So this one is number 1 point. Also we know that RIP uses UDP as its transport protocol with your port number 520. Okay, the next one about the OSPF, it directly encapsulate. So these are the characteristics. Okay, from this we will find what are the correct one. So OSPF directly encapsulates, data directly into IP address. Okay, so according to this, so see, distance vector routing, so this is one is correct. RIP packets are sent using UDP, so according to this, this is also correct. OSPF packets are sent using TCP, but and another option is OSPF operation is based on link state routing. Okay, so this, among this is wrong. Okay, and this is correct. So 1, 2 and 4, 1, 2, 4, that is option C is correct. Okay, so this is correct. Now let us go for another GATE problem. It is also came in GATE 2017. Okay, the problem is the maximum number of IPv4 router address that can be listed in the record route option field of an IPv4 header is this one. So fill up the blanks. So that is the maximum number of IPv4 router address that can be listed in the record route RR option field of an IPv4 header is this one. Okay, so you have to calculate this. Now you know, you need to remember this one, that the length of the option field in IPv4 header is equal to 40. Okay, 40 bytes, and out of which 2 bytes are reserved and hence 40 minus 2, 38 bytes can be used. Okay, so this you have to remember that 40 bytes out of the option field is 40 bytes, and out of which 2 bytes are reserved and 38 bits you can be used. Okay, and we know that length of IPv4 packet address is equal to 32 bits, that is nothing but 4 bytes. Okay, so therefore maximum number of IPv4 addresses is 38 divided by this 4, which we take the floor value, which will give you the answer 9. Okay, so your answer will be 9. So what you have to remember, that is that 40 bytes, the length of the option field is 40 bytes, among 2 is your reserved, so 38 bytes are available. Length of the IPv4 packet is 32 bits, okay, or 4 bytes. So if you divide this, then you will get maximum number of IP addresses is 9. Okay, so this one, another problem we have done. Okay, we will do another problem. Okay, so for that I need a much space. Okay, yeah, that's fine. Now this is some typical type questions. It is also came in 2017 GATE computer network. Okay, so it's given that a message is entirely made of characters from the set X equal to PQRST. The table of probabilities for each of the characters is given. Okay, so characters, and this one is probability. Okay, so P, the probability is 0.22, Q 0.34, R 0.17, S 0.19, T 0.08. Now if you add all this probability, obviously you will get 1. Okay, so it is given that if a message of 100 characters over X is encoded using Huffman coding, then the expected length of the encoded message in bits is this one. So you have to calculate this. If a message of 100 characters over X is encoded using this Huffman coding, then the expected length of the encoded message is in bits is this one. Okay, so what we will do, we will arrange in some format this one. So to solve this, first we will consider the lowest probability will have the maximum number of length. So what are the lowest probabilities? This T, and second lowest is R. Okay, so let us, we will make like this way. So T, that is your 0.08, this one, and R 0.17. So let us see how we will solve this T and R. Now both, if you add this one, you will get 0.25. This is the probability. Okay, and after this, what will be the next two one? So this is 0.25. Next two is this one, that is first you take 19 and 22. Okay, 19 and 22, that is P and S. Okay, so 0.19, this is your S, and 0.22, this is your P. If you add this, you will get the probability 0.41. Okay, now let me add another thing. Now left is Q, so Q is left, so Q we will add with this one, 34 we will add with this part. So you will add this with Q. So what we will get? So first this one, that is 0.25, 0.08, this is your T, 0.17. Okay, these are the probabilities from this, and you will add the left remaining is your Q. So Q is this one, 0.34. Sorry, this is P, R, and this is Q. If you add this, you will get 0.59. Okay, so this one. Now this you get, and this you also get. Now add, you add first this P and T and R, the lowest two. Then again the lowest is, according to this you will find that S and P is the lowest, so you add this two. Again you will add with Q with this one, you will get this. Now add this one with this one. If you add this portion with this portion, you will get, ultimately your probability will be 1. So I am writing the 1 over here, and 0.59, then 0.25, then it has two parts, 0.08. Next one is your 0.17. So this is T, this is R. This you will get the Q. Okay, so 0.34. This is your Q. This is 0.41. That is this one. You will get first 0.19. Next one 0.22. Okay, so and this is S, this is R. Now I will do what? All the left branch I will consider is all zeros. So 0, 0, 0. Right is 1, 1. This is right, so 1, 1. But this is left, so I will consider it as 0. Okay. So now try to represent the values. Okay. So by doing this, now if I want to represent P, P means what? P, you see that S and this is P. Okay. So this is P. So P is what? P is 1, 1. Q is 0, 1. Q is obviously 0, 1. PQR. R you need 3 bytes, 0, 0, 1. 0, 0, 1. Similarly S 1, 0 and T 0, 0, 0. So this required 2 bits. This is 2 bits. This required 3 bits. Again this 2 bits, and this required 3 bits. Okay. So now we will find the average length per character. Okay. So average length per character. So 2 into, now to find this we will multiply these 2 bits with the probability. Okay. So p, what is the probability of p? That is 0.22. Okay, plus 2 into probability of q is 0.34, plus 3 into 0.17, plus 2 into 0.19, plus 2 into 0.08. okay, so on an average you will get 2.25 bits. okay, now for a message of 100 characters, it is given that for a message of 100 characters, so average length per character is this. So for 100 characters, it will be 100 into 2.25, that is 225 bits is required, because for one character 2.25 bits, for 100 characters you need 225 bits. So your answer will be 225 bits. okay, so this is basically a tricky question, a new type question. okay, hope you understand this and have solved this. okay, so all the GATE 2017 and 2016 questions on computer network have been solved. So we will solve the algorithm portion in the next videos. okay, thank you.